Hello everyone, I'm Sayam Pathak and I'm CNCF ambassador, and I run a YouTube channel where I do live streams on cloud native technology. So for today, we will be exploring Chaos Mesh, Chaos Engineering tool, very clear from the name. Okay, I'll present my screen. Yeah. So this is my YouTube channel, and you can see Twitch streams. I have created a new section where I'll upload all my previous Twitch streams. So first we try to understand what is chaos engineering itself, and then we try to understand what chaos mesh is. So the thing is, whenever we are now building our systems, whether it's production systems, small or the big ones, so the resiliency of the production systems is very much important. And as of now, you can not just use a single tool and test your applications. So you need to periodically, or actually in a continuous way, which we call CI/CD types. So in a continuous way, you need to inject chaos. Chaos means a certain what you call you are creating a disruption in some way. For example, maybe deleting a pod in a particular namespace, deleting a network pod, increasing the amount of traffic, and things like that. So you are creating some sort of disruption within your cluster, and you see how your cluster behaves. Because in production, things can go wrong, and they can go wrong in a way that you would not have imagined in first place when you were building those. So in order to prevent those, there are various chaos engineering tools that lets you inject different types of chaos, means different types of the disruptions within your Kubernetes cluster, because we are using this terminology again and again, Kubernetes cluster. And then you can predict then you will be getting the results, whether your tests have been passed, or what is the impact. And if there are any flaws, then you find them actually before they happen. So before even they are happening in production, you find them and try to then solve it. So you define the blast radius and all those things. So basically resiliency of the your production systems, and monitoring your, it's kind of you are pre-monitoring your system for failures even before they actually occurs, and that's what everybody wants for their production. So you can manually or using the chaos engineering tools, inject all these chaos and keep injecting them with the certain intervals, or with certain triggers, so that you know how things behave when things go wrong, and how you can solve them. Or the Kubernetes automatically is handling some of the things for you, or you have already taken care of all such incidents that might happen. So you can see that killing the pods, spiking load in the cluster network traffic, these can be done, and they should be conducted in a kind of a scheduled manner. And obviously they are different from the regular testing, because regular testing just validates a particular property. But your chaos engineering, so you have a 4-step experimentation process. We define the steady state, and then we hypothesize that the steady state will continue in both control group and the experimental group. Then we introduce the variables that reflect the real world events, like that, the crash, and all those, and try to disprove the hypothesis by looking the difference between the steady state and the experimental group. So I mean, yeah, you can give a complete read, and I have told about the two of the tools as well, Litmus and Chaos Mesh, and this is what we are going to explore today, which is Chaos Mesh, this one. So that was about chaos engineering. Now let's move to Chaos Mesh. So what is Chaos Mesh? Obviously, Chaos Mesh is chaos engineering platform that orchestrate chaos on Kubernetes environment. And it has two things. One is the chaos operator, which obviously is the core component, and another is the dashboard. So from the web UI, you'll be able to create and manage, and create the experiments and see what all is happening. Now there's a quick overview here, or there's a quick overview on my channel as well. So you can see this one. So I do CNCF minutes, and this is on Chaos Mesh that I have done. But anyways, we are now using the documentation itself. That's how we explore a new tool. So feature wise, it's easy to use, no dependencies. Chaos Mesh can be deployed to any Kubernetes cluster. Minikube, kind, K3s. K3s is something that we'll use today, and any regular Kubernetes distribution. And it is designed for Kubernetes. So all the experiments uses the CRDs. So we can write a custom resource for the experiments. So we'll do a kubectl get CRDs and see what all custom resource definitions are installed when we installed the Chaos Mesh. And CRD is just an implementation of custom resource with obviously the use cases and extending the writing the resource in type of a YAML file, which I'll show you. So this is the feature wise. Let's see the architecture. So this is how the simple architecture looks like. On the left hand side, these are the chaos experiments. So pod kill, pod fail, network loss, network delay, network drop. All these are the chaos experiments. And you write a YAML file, the CR, which I was telling, and give it to the controller manager. So this will be kind of when you install the chaos operator, the controller manager will be installed. That will be reconciling the states of the YAML. So as soon as it gets submitted, so it will take care and run the experiment. So there is a daemon, chaos daemon pod, which runs. And then you have your container on the particular node where your chaos runs. And then it will, do its particular job. Concepts. Very simple concept. Chaos engineering is a discipline of experimenting on a software system in production in order to build confidence in the system's capability to withstand the turbulent and unexpected conditions. So I have explained you in simple terms. Let's move to blast radius. So that also I was telling you about, because we are running in production. So sometimes the customer can face outages because if you kill some of the pods of the production where the traffic is flowing, then it might be painful. So you have to carefully design how to run the experiments when you are running in production. And getting started. So what we'll do is we'll do installation, but we'll do installation on, so there are a lot of installation steps. So you kind on Minikube and there should be on K3s as well. So install on in the containerd environments, which is K3s based. Now let's go to the terminal. Kubectl get nodes. I hope the cluster is up and running. Okay, the cluster is up, and let's create the namespace. Helm tree. We have Helm tree, and it is doing a Helm install Chaos Mesh. These are the chart repository in the namespace that we just created, and then it sets the runtime, which is containerd, which is important because it's K3s, and also define the socket path. For Docker, it is docker.sock, and similarly for containerd, it will be run K3s containerd because in the K3s one, it is in this particular directory. So let's copy that. Oh, I have to do a Helm repo add. Have they done? Okay. I didn't add. Let me just add it. Added, and let me just search so that it's there. Cool. It's there now. Let's install it. Creating. Awesome. So it has created everything. So let's run this particular. Okay, this command was here itself. Let's see whether it has started something. Okay, it has started two things, which were the major components, the chaos dashboard and the chaos controller manager. So these are the two main things that has to be ready. And let's see if the daemon is there. So I think chaos daemon has to run on each node. That's why it is there. And let's see if it is there. So now we have all the 5 pods which are there as per the documentation. as per the documentation, it looks good. Now what we'll do is, let's see, run the chaos experiment. So the first step is to deploy the testing cluster. Okay. Define the chaos experiment and apply the chaos experiment. So what it will do is it will inject the latency in a particular pod. Okay, let's see. We have the testing cluster, and what they are doing is installing an application which is web show. What is this web show application? Okay, this is a sample repository web application. So let's run the same one. Copy. So it has created a service deployment, and it waits the pod to be running. After executing, you can access localhost 8081 in the browser, and it will show web show application. Okay, we'll test that, or we'll change it to node port maybe. The pod is running. Looks now. kubectl get counts. Web show pod is running. kubectl get svc. We have svc running. Let's change this to output, just for simplicity's sake. And we have node port. Now we get the svc, and we get svc. Okay. So let's try to see if we have the web show application running. Okay, this is running good. This is a simple application that is happening, and what we'll do now is, okay, it is giving some of the inputs for the latency, which is fine. Now let's inject the chaos. So how we are defining the chaos now? What we'll do is, first kubectl get crd. So you can see when I did a get crd, it has given me some crds related to chaos mesh, which is like the DNS chaos, HTTPS chaos, IO chaos, kernel level network, pod IO, pod network, stress. So all these chaos are there, which I'll show you in the dashboard as well. But they are here as a CRDs. So we can create a custom resource, which is this file. So we'll create a kind network chaos, so which will be of this CRD. So this is the network chaos CRD, which is already there. So it will be able to understand this particular YAML file. So that's why we have network chaos. Now this is the name, and we do action as delay, and mode is basically to run chaos action. Supported modes are all fixed percent, random max percent. So here by default it is 1. Then selector, basically which pod we have to select. So in the default namespace, we have a application with the app label web show that we are targeting. So it will target this particular pod, and it will delay the latency by 10 milliseconds for 30 seconds as a duration, and it will run every 60 seconds. So let's run this. Apply this chaos experiment. So let's save this. Copy vi net chaos.yaml and kubectl create kubectl and use apply -f net chaos.yaml. So we have applied this chaos, and I think now when we see the graph, we should see something pretty cool. So kubectl get svc-a. Let's see where we have our chaos mesh service. This is the dashboard. It's already a node port, so let's visit it. 31956. So let's see in the dashboard what is happening. Cool. Okay, let's create the manager. RBC YAML cube TTL hyphen F REC, and then describe the secrets. We get the token. We submit the token and we wait. So we have everything over here. So this is the chaos mesh dashboard, and we can see there are different levels of experiments. I mean, different kinds of experiment like pod, fault, kernel, DNS. And for the network one, we have one running. So let's go to the experiments. And it was created for 8 minutes ago. And let's click and see if it is running actually or not. So it says that it ran and it has ran so many times, and you can see it ran successfully and it finished. So, oh yes, we can see, right? We can see the latency now. So it's 10. I don't know why this was not refreshing earlier. So we can see the 10, 10, 10 latencies over there. So the chaos is properly injecting all the traffic. So I think the docs are pretty neat, and I was able to very neatly do all the things. So chaos dashboard is already there, and now let's move on to the next part. I think we are already done. So what I wanted to show you is what is chaos engineering completed. What is chaos mesh? We saw that from the docs. How to install chaos mesh on K3s cluster, we were able to do that. How to run a basic experiment of network latency on a sample application as per the docs, we were able to do that. How to see the UI, we are able to do that. Let's explore the UI and we'll finish off the stream. So we have the events that I showed you, and we can just zoom in, zoom out just to see the time. And we have the experiments, and we can create new experiments. That is the good part. So we can create maybe a pod fault, maybe a container kill. So kubectl run nginx image default nginx image submit done. So you can see the new experiment was very simple to create. We can create something called batch operations, and events is fine. Archives, I don't know what archives are for. Okay, archives are for the batch operations. Cool. Settings for adding API tokens, and I think we can add multiple API tokens from multiple clusters. Then the view will change maybe. And debug mode, allow to select kube system namespace scope while creating an experiment. We have a dark theme. Ooh, fancy. Yeah, that's pretty much it. Very simple UI, sleek UI, and lot of experiments, to be honest. And ever increasing, obviously. So you can see there are experiments. You can see in the dashboard what is waiting, what is running, and you can also see the graph, the timeline, when it is running, when it ran. And there are different levels of experiment like network, IO injection, stress test, kernel level. And for different there are different amounts of options that you can select either from the UI, or you can directly go to the documentation, select one of the experiments and create a CR for that, which is also I mean, for the basic example for which is also given. So that's pretty much it. I hope you like chaos mesh, and give it a try. Tag them on Twitter that what you have learned for the chaos mesh, and obviously do not forget to subscribe to the CNCF Minute series. We'll try to explore all of these projects, what they work, how they work, and from the scratch the installation. And also do not forget to subscribe the channel. A lot of great content coming over the next few months. And yes, obviously you have to subscribe to my Twitch, which is twitch.tv. So you have to subscribe to Twitch as well so that you get notified whenever I go live. So why we use it? Yeah, again, so we use it because to create the experiments, to create the chaos in the cluster. So we have to know, like for the current experiment itself, which was the network chaos. So we are inducing a delay. So basically, whenever a delay happens, then what happens to the requests, and how well we handle that. Whenever a whenever a container kill is happening, for example, if we go here and we do a stress test. So whenever we do a stress test, or there's a load on CPU or something, are we able to handle it, or are there any other pods, how many replicas are needed? So all those actions are taken care. We can do a DNS attack, we can do a full network loss and corruption, and the bandwidth also. But again, this has to be taken care with respect to the blast radius that you do, because since you will be doing it in a continuous manner in production, so you might dedicate a particular namespace with a particular workload which is similar to the production workload and do the experiments, or there can be other scenarios as well. Then kernel level faults, you can include the call chain, and these are some AWS faults that you can directly include and see what happens and how well you can be prepared if these things happen. So like this, chaos engineering helps you, and this is, I mean, this technique basically is growing too much. That's why we are seeing and number of tools that are coming up. Like Litmus is there. I did a video and even the KubeCon demo on that, which is pretty interesting. There I show the Flux as well, how you can use Flux, the GitHub Actions, the Litmus, and the K3s. So all these things, and how you can create the chaos and do it in a continuous way. So things get really interesting when you attach GitOps to chaos and do it in a continuous manner, and see what all failures will come and how you will be able to tackle it, or how well your system is already to able to handle all these things. So I hope I was able to answer your question. And yeah, so I'll shop this share. It deals with the load on containers. Yes, the stress, I have to check. Stress test would be on the containers, yes, obviously, because we will be doing the stress testing on that in the pod. So we have to specify the pod and all those stuff, the selectors basically. So the scope section that I showed you, there's a scope section which I showed you. The scope section defines which particular namespace and pod this has to apply. So it will only apply to that particular namespace and that particular pod, or that particular set of pods. So if you have deployment with label app nginx and there are 3 replicas, so it will pick one of those, because that's what it has to choose a pod based on the label and the namespace. So, and that also automatically gets popped up in your dashboard. For other things, for the YAML, you have to write that. Okay, got it. Thank you. So thank you for tuning in, and I'll post this recording with some of the editing if required, and post that on YouTube as well, so that because there's a 15 days that it stays on Twitch. After that it goes, but I want to keep it because it might help in future. So thank you all for tuning, and see you next time.